So our last topic with properties of logs, yeah, it just increases in level of difficulty, makes you think about a few more things here. Realize that for this, I do expect to see some very simple kind of algebra mistakes, or even you get most of it wrong, but you just enter the answer in incorrectly. So make sure your work is very, very clear on these questions. So you can see the original here. Again, we're trying to solve for x. We still have a common base of 6. One thing that we notice here is that we are adding. So that means we're going to end up multiplying the parts of the log. Okay, so I can start off by saying I have just one log base 6, but now I need to multiply 2x minus 3 times the x minus 2. Those are the two things that are inside the two separate log equations or log ideas in green. Since we're adding, we would multiply those things together. It's still going to equal 0. If I wanted to, I think your key tends to not show this right away, but certainly I can do this if it helps. I can actually go through and FOIL this together. So what is 2x minus 3 times x minus 2? You can show as much work as you want to for this, but I would get 2x squared from the f part of FOIL. From the outside, I get 2x times a negative 2, so negative 4x times a negative 3, or to that I'm adding the inside part, which is negative 3 times x, so negative 3x. So again, that's a negative 4x and a minus 3x. That gets me minus 7x. And then the last part of FOIL would get me a positive 6. And that's still going to equal 0. So sometimes the keys on this, they don't do that as the first step, but that's probably what I would do, is just kind of show what that's going to equal. Okay, so now we have that as just one log idea, but the only way I can really rework that is to write it as exponential. So I'm going to have 6, the base of 6 raised to the 0 power, right? It's the power way far away, and that's going to equal 2x squared minus 7x plus 6. 6 to the 0 is anything to the 0 power is 1. Okay, so I get this then. And if we're going to solve this quadratic, so it's going back to our last unit, how do we solve for x here? I need to get one side to equal 0. So I'm going to subtract 1 from both sides, and that means I have 2x squared minus 7x. If I subtract 1 from both sides, I'm going to have a plus 5. Okay, so if you can get this far, you're in very good shape, because I think that is using all the stuff that we're talking about right now. Oops. That's not what I wanted to do. We'll get this up there again. Oh boy. Let's go back to, there we go. All right, so now how do I break this apart? So you can go through and you can do the entire version of FOIL, of doing our little trick if you want to. That there's no issue with that. If you did that, you would figure out what is A times C. Okay, and that's 2 times 5. Which is 10. Okay, your B value is negative 7. Okay, and what are two numbers that multiply to positive 10 and add up to negative 7? That'd be a negative 2 and a negative 5. Okay, so if it's helpful for you to actually write that out, go for it. But now what I'm going to do is I'm just going to rewrite the original thing that was in red. But instead of minus 7x, I'm going to have a minus 2x and a minus 5x. And I still have the plus 5 over there. Okay, so now we're getting into that factoring sort of idea. We look at what do those things right there have in common. Okay, so the first two parts, they would have a 2 and an x in common. So we're going to have 0 equals, we're going to take a 2x out. I'd be left with an x in the first part and then a minus 1 in the next part. Okay, if I look at what the next two parts have in common, they obviously have a 5 in common. I'm actually going to factor out a negative 5 so that when I factor that out, I'm left with a positive x and then a minus 1. Okay, so just think about distributing a negative 5 to both of these. If I distribute a negative 5, I get negative 5x, which I want up there. And then a negative 5 times a negative 1 gets me positive 5. So that's why I decided to do that. It's not a super common problem that you're going to see, but it does make things match up nicely. Okay, so now what do they have in common? They have that x minus 1 in common. And what's left behind? We have a 2x that's left behind and a minus 5 that is left behind. So if we're going to actually factor this, that means that out of the two chunks, somehow one of them has to equal 0. So that means either x minus 1 could equal 0 or 2x minus 5 could equal 0. For the first chunk, x could equal 1. And for the next chunk, if I thought about it long enough, I would get x equals 2.5. Okay, so there's a lot going on there. There's some review in that last little part, and I do expect there to be some simple mistakes that we make as we go through that. So don't be alarmed if that happens. I'm expecting it, but it's just something to be aware of. The other thing that could cause some issues here is for these answers that we have there of 1 and 2.5, we need to realize that the log equation will only work if we end up with something that's positive in these things. Okay? So if I were to plug my answer of 1 in here, if I plug a 1 in there, so 2 times 1 is 2, 2 minus 3 is negative 1, I get a negative 1 in there. I can't take a log of a negative number. And if I plugged it in over here, I get a negative 1 there. I can't take log of a negative number. So 1 is kind of an extra answer here. We actually are not going to use it. But if I plug that 2.5 in, it's okay, because 2 times 2.5 is 5. If I subtract 3, I still have something positive here. And the same thing would happen over here. So when I go and enter in my answer, I do need to kind of double check what I have. In this case, I'm just going to answer 2.5. It should take this. It may like 5 halves better, but I think 2.5 should be okay. And it gave me the right answer, okay? Then they kind of go through and show a lot of that work. They happen to use quadratic formula for this. But here they're showing the check here. And again, it's because in the original, I need to have a positive result from what's all here and from what's all there.